This conference will now be recorded.
Right. So let us understand in detail about the inheritance, and we see what are the different types of inheritance in this session. Okay. So if you look at the basic inheritance, what is inheritance? Okay. If you look at inheritance, is one of the key features of the object-oriented programming, right? In object-oriented, the major or the four pillars of the object-oriented programming, okay, are encapsulation, abstraction, polymorphism, and inheritance. These are the four pillars of the object-oriented programming concepts. That's what you used to say as four pillars. Out of them, so we are discussing about the inheritance. What is inheritance? So inheritance is a concept. It's a mechanism where we are inheriting one class properties into another class. We are inheriting or we are acquiring the properties. The properties are nothing but variables. Can be variables, can be methods. So we are acquiring them from one class into another class. So we are relating these classes using easier relationship. So these two classes are having easier relation. So here is an example: person and employee. Person and employee. We can inherit a few properties of person into employee. However, employee has its own properties, its own set of fields. Still, it acquires a few properties from the parent class, which is the person here in this example. So if you look at here, the person class is known as a base class or a super class, the parent class. A different terminology we have here: the super class or a base class or a parent class. Here, if you see, the person class has few set of properties: ID, name, age, date of birth, Aadhaar number, and its constructor and setters and getters goes here in this particular class. Now, so I'm acquiring the properties of person into employee. So here is my employee class, where my employee class is extended by person class. So I can say employee is a child class. So this child class termed as a subclass or a derived class also. It's derived from person. It's extended by a person. Employee extended by a person. Employee is a child class. Person is a super class. Person is a super class, right? So here, what are the specific properties of employee? Only two: date of joining and salary. These are the two specific properties of employee. But if you look at the constructor of employee, this is what the constructor of employee. It has more properties which are initialized as part of the constructor. What are the properties? ID, name, age, date of birth, and Aadhaar number. So all these properties are inherited properties. These properties are inherited from the parent. So if you look at the parent class, so these are the set of properties we have in parent person class: ID, name, age, date of birth, Aadhaar number. So those set of properties are inherited from person. So we did not initialize or declare those properties here. We are just initializing as part of the constructor. Do we mention those properties here? No, not required. But still, those are available to my employee class or not? Yes, they are available because my employee class is extended by a person class. And what about these two properties, date of joining and salary? So these are specific to employee. So all the properties all together I am initializing as part of my employee constructor. So if I create a new object for employee, employee will have ID, name, age, date of birth, Aadhaar number, date of joining, and salary. Out of it, in my class I have only declared two properties. What about the other properties? These properties are declared as part of its parent class, which is person here. Person class is a parent class, employee class is a child class. The child class is also known as a subclass, derived class. Can also termed as a subclass or a derived class. The basic understanding about inheritance. Okay, so and the main advantage of inheritance is reusability. The main advantage of inheritance is reusability. Okay, inheritance supports the concept of reusability. That's what, when we wanted to create a new class, okay, and there is already a class that includes some of the code that we want, we can derive our own new class from the existing class. Okay? So here in this example, these properties we are using, these fields we are using, of course, if the parent class, person class has some other methods, and those methods can be inherited into child class. Not only fields, methods also. So any non-private members of the parent class can be inherited into child class. Non-private. Okay. Private properties cannot be accessible into its child classes also. We'll discuss about the access modifiers after, like, maybe tomorrow. Okay, if you see here, as the methods also inheriting into child class, nothing but what, so we are reusing that, we are reusing the same method code in my child class instead of rewriting the same logic again. So that inherits, and I can make use of it without rewriting. This is what called reusability. The main object or the main mode of inheritance is called reusability. So however, we have different types of inheritance: single inheritance, single level, multi-level, hierarchical inheritance. Before looking into that, let's understand this code reusability in terms of methods. Okay, so here I have employee class with the two properties, person class with all the properties. Let me take a new example. I'll take a new example. New class. In the new class, I'll just say, okay, base class. Okay, base. I will take one more class. I will create one more class, derived class. Okay, or subclass. Base class and subclass. And so, as I am speaking about inheritance, so my subclass should be extended by base class. That's what I'm doing it here. Subclass is extended by what? Base class. Now let me define one property, string class name. I'm just giving class name a property. What is the property? Just a class name. And here I'm writing one method, public and returning the name of the class string get class name. So what it is doing is it is printing the class name is okay, this dot class name. This dot class name. Okay, I don't want to return anything, just that's it. Okay. So it is just printing the class name. So in base class I have one property and I have a method. Now I'm going to child class. This is what's child class. My child class does not have any properties. My child class does not have any properties. However, so I'm going to create a main method, and I would want to create object for subclass. I wanted to create object for subclass. I want to create object for subclass. The subclass dot class name. Am I able to access that or not? Class name. What is this class name? If we look at the class name, it's going to print the class name, and I wanted to call subclass dot get class name. If you look at, so what is the underlying object here? What is the object here? So if you look at, I have created object for subclass. I have created object for subclass, and on top of subclass reference sc, I'm able to access the class name and get class name. But in my subclass, do I have this variable field? Do I have the method get class name? No, but still I'm able to access it, and of course I can execute also. And if you see the output of it, so you can see null class name is null. So it is executing or not? Of course, as we did not initialize that property, class name, so you don't see that. You don't see any value. It's printing null. Now what I do is I'll initialize it. I will write a constructor here. I will write a constructor here, subclass. This is what my constructor. In the constructor, what I do is I will pass a name to this. I will pass a name to this, and here what I do is I'll simply call superclass constructor. I will simply call superclass constructor, and in the superclass constructor, where is my constructor here? Let me write the constructor here. Base class constructor, base class constructor, base class constructor here. Uh, let me have the same property because I wanted to initialize this class name. My class name, I wanted to initialize this dot class name is equal to class name. This dot class name is equal to class name. A simple example. A simple example. Now go to the child class. Where is my child class? Subclass is my child class. So here from the subclass constructor, I wanted to call superclass constructor to initialize that particular property. So what I can do, I can simply pass this name as a parameter to the superclass constructor. This is how we will pass the parameter to the superclass constructor. Now, as my subclass is expecting one parameter, so while creating the object, so do I need to send that argument or not? Yes, of course. So just give the name subclass name. So this is a subclass. This is a subclass. This is a subclass, right? Now what will happen? As soon as you create the object of the subclass with this particular name, it goes here, it goes here. The name will be having what name? This particular string. This is a subclass, and this is a subclass string will be passed as a argument to the superclass constructor. So it comes here now. This class name have the name. This is a subclass, and that will be initialized with the property class name. Getting it? And then after, if you try to access sc.class name, yes, of course, the class name is initialized with this already. You are going to get this is a subclass, and then you are calling this method get class name. So get class name, it comes here class name this dot class name. The same thing, right? Whatever I have accessed here, the class name, whatever the class name you have given, the same thing it is going to print. You see this. So this is a subclass, and class name is what? A subclass. So I did not write the property or the method in my subclass, but still I am able to use those properties and methods of base class into my subclass. That is what a concept of inheritance. That's where we are getting the code reusability. I did not declare that, right? I did not declare the property, I did not define the method, but still I am able to use that. So in this case I have only one line of code, but in real time example you would be seeing hundreds of lines of codes, and you can get all the methods, all the public method, all non-private things, basically you can say all non-private members can be inherited into child classes, so you can have a number of methods in your base class. All the methods can be inherited into child class without the rewriting. You can make use of them without rewriting, right? Okay, so this what code reusability. I have reused that method and properties in my child class. If you want to create object for parent class, okay, I wanted to create object for base class. Base class is equal to new base class. So this constructor is expecting a string variable, so I have to send that. So what I will give is this is a base class. This is a base class. So bc dot get class name. I'm just calling. Okay, base class. Now what is the object now? Base class only. Here the object is subclass, but here the object is base class itself. Here the object is base class itself. So if you see, of course, it will say class name is base class, and in the above it is going to say class name is subclass. So this is how you can send the class name to the constructor of the base class and from the child class. So how I'm initializing the subclass name again. So in the subclass constructor, from the subclass constructor, I'm calling the superclass constructor. Nothing but what? This is what? The same thing. So again, it goes to base class constructor. Whatever name you are passing, that name will be initialized with the class name. And when you access the class name, whatever the name you initialized as part of this object creation, the same thing you are going to see as part of code. Understand? Base class and subclass. Base class and subclass. So acquiring the properties of parent class into child classes. And if you look at the types of inheritance, we have single inheritance, multiple inheritance, hierarchical inheritance. So single inheritance is this is what the example. So it's only one level. So one parent, one child. One parent, one child, no other classes involves. That's what simply single inheritance. That's what we discussed. And the next thing is multi-level inheritance. Multi-level inheritance. If you look at single inheritance is a subclasses inherited the features of one superclass. One superclass, that is important here. So only one superclass and only one level. So base class and base class and subclass. Here class A is my parent, class B is my child to the A. And when it comes to multi-level inheritance, okay, you can have n number of classes in between. You can have n number of classes in between. Okay, I have class A, class B, class C. Class C is the child class of the class B, and class B is the child class of A. But when you look at these two relation, class C is the child, class B is the parent. But when you look at this class A and B, class A is the parent class, class B is the child class. But like this, you can it can go any number of levels. There is no limit. Okay. So say for example, I have classes. I have class A. I have class B. I'm just creating class B, and I have class C. This is what multi-level. So I have three classes A, B, C, and as of now, all three classes are independent classes. Class A, class B, class C are independent classes. Now, so as per my diagram, so it is class A is extended by class B, class B is extended by class C. So let me have that relation here. Class B is extended by class A. Class B extended by class A, of course. And what is the name? Class A. It is class A. And class C is extended by class B. Class C extends class B. Class B extended by class C. Now in class A, assume that in class A I have a property A. I have a property A in class A. And in class B, I have a property B. And in the class C, I have a property C. Okay, so I have taken one property in each class. Right. Now I wanted to write a method here. Okay, print properties fields. So this is what my method. I don't want to return anything, so return type is void. I wanted to print the values now. So this dot, what are the available properties I have in C class? If you see here, Eclipse helps you. If you just do after dot, if you just do control space. So this dot A, I can access this dot A. I can access this dot B. I can access this dot C. So I can access all the three properties. A, this is what? It's own class. Property of what? So own class property. Yes or no? A, not this one, right? This one. And what about A? So A is inherited from class A. It is inherited from class A, and this is inherited from class B. But I'm able to access all the properties or not? So the property can be inherited through multiple levels. A is inherited into class B, and from class B it is inherited into class C. That is what it is available, the A is available in class C. Its immediate parent is class B. Okay, in class B you don't see the property A, but class B is extended by class A. There you have a property A, so you can access the property in class C. It's a super, it's a grandfather. Okay, and if you look at B, so I don't have B property defined in class C, but how I'm able to access it? Because it is inherited from class B. Class B is having the property what? Right? Okay, now let me define a constructor on each class. So in this constructor, I'm going to initialize my A value. I'm going to initialize my A value. This dot A equal to A value. This dot A equal to A value. And in the B, I will create, okay, class B is what class B constructor. Now, if you see interesting point, okay, so class B, so can I just have B value, and this dot B is equal to B value, right? So this is a constructor, but if you look at it's started giving error. What is that error? Okay, so implicit super constructor class A is undefined, must explicitly invoke another constructor, must explicitly invoke another constructor, meaning that was if you wanted to create an object for the class B, the class B constructor, whatever you have defined implicitly, even though if you don't write internally, it's going to have a call. This is super call. We are going to have the superclass constructor. But if you see the superclass constructor, we don't have on the class A, we don't have a constructor with one parameter. We don't have a constructor with one parameter. Constructor with no parameter. We have a constructor with one parameter. We have a constructor with one parameter. That is the reason it's giving error, meaning that so it starts calling this. It is to by default internally compiler places this super call. And if you are writing a parameterized constructor, it keeps a super constructor default constructor call. But if you look at the superclass constructor, there is no default constructor in class A. In class A, we don't have default constructor. In that class A, so this is my default constructor. If I write this is what default constructor where it doesn't have any parameters to be passed. Now see that the error is gone up. So now no error, no error. So that is what when you are writing constructors for initializing when with the parent child, it's very important to understand the things very clearly. Now let me write class B with no parameters, because we can write multiple parameters. We can write multiple parameterized constructors, right? So constructor with the parameter, constructor without no parameter, right? So it's possible. This constructor with no argument, this constructor with an argument. Now if you see, this is also calling by default construct compiler places a constructor call by default superclass constructor, because this is no argument constructor, so it's by default calls the superclass constructor. It doesn't have anything to initialize in the superclass default constructor. Okay, now but if I wanted to initialize my a parent class superclass property also, then while creating my child object, then you will have to add that property also. What is the inherited property? A. So I wanted to initialize a value. I wanted to initialize this a value. A is equal to a value. So can I initialize here? Yes, of course I can initialize it here. I can initialize it here. Okay, so for now just I'm initializing this property here. Now go back to class C, and here also I do the same thing. Okay, class C, this is a default constructor. Class C, parameterized constructor. So here in class C, I have three properties, right? So A is available, B is also available, and C is available. So I have total three properties, and three properties to be initialized. I have to initialize all three properties. A equal to A value, this dot B equal to B value, this dot C is equal to C value. I had to initialize all the three properties because class C is having three properties A, B, C. A is inheriting from class A, B is inheriting from class B, and C is its own property. So total I have three properties to be initialized as part of its constructor. So that's what I have written here. Are you good so far? Hope you are following. Now, okay. Now let me write a test class to test these three classes. So I will write class test multi-level inheritance. Multi-level inheritance. I have a main method. Now I wanted to create object for class here. Class A. Okay. A object. A object is equal to new class A. So class A, so how do you want to create object? You wanted to initialize during the object creation, or you wanted to initialize it later? If you want to initialize the properties of class A later, then just go with the default constructor. Create the object first and later you initialize using the setters and getters. No, I wanted to initialize during the object creation itself, then you use the parameterized constructor. New class A, what is the A value? So I'm giving 10. A value I'm giving 10. Now in a similar way, I wanted to create object for B. Class B object is equal to new class B. So let me give value 20. But see here, it's giving error or not. So the B object is giving error. What is that error? So it is expecting two arguments, right? So class B of with one parameter it's not available. So it is expecting class B is expecting two parameters. What are the two parameters? B value and A value. So first parameter is B value and next parameter is what? A value. So A value I'm giving say okay, so 100 I'm giving. Now in the similar way I'm creating class C object. How many parameters I have to pass? Three parameters. So C value, say let me say 30. Okay, C value and B value and okay, and A value, something like that I'm giving. Now, okay, now I wanted to print A object dot A object dot A. I want to print B object dot A. I wanted to print all the properties. A dot B, and for C object, I want to create C object dot A, C object dot B, C object dot C. Can you guess what are the outputs? What are the outputs that I can expect? So here, what is the object here? A object. And what is the value of A here? So can we get 10 over here? So we'll get 10 over here. And here if you see b object dot a, b object dot a. So here it's initialized the properties here. What is the a value here? We get 100. What is the b value? 20. And in this case, object dot b, what is the b value? 20. I'll get c. Well, let's validate. I'm going to get as like as this straightforward way, or is it going to do any manipulation? Okay, change the values. Okay, in the child class C, what is the value a? So 30. So if you see the constructor, how it is initialized, a value, b value, c value, in order it is initialized. So a value is 30, b value is 50, and c value is 70. And after that, again, if I call um, a object dot a value, what will be my value now? Is it going to take this 30, or is it going to take 100? How it is going to print? If I print my values again, so b object dot b, how it is going to print the values? See, on this, compare the outputs. Okay, first one is 10, then 100, 20, and then 30, 50, 70. Again, if you see a object dot a, what is the value? 10. B object dot b, what is the value? 20. So here in the C object, I have the value 50, and the B object value is 20. When you access the property using B object, it is going to return that particular value associated to it. And when you access that property using C object dot B, C object dot B. So this is going to return a B value from the object C. That is what 50. That is what 50. So what is the understanding here around is B object dot B is 20. So the understanding here is, so every object has its own separate copy. So it's not going to override any values of one object to other object, even though it has, you have defined in different classes, and you are accessing all the properties into other classes and initializing there. Every class object has its own copy. Every class object has its own copy. So here, what is happening here? So I have a class A and its property A, and I have class B. I have a class B here. I have a class C. So here I have a property B, and here I have a property C. But as okay, the link is in. Okay, so this is inheriting from this, right? So class B is extended by class C, and of course class B is extended by class C. Now if you look at, as this is extended by class A, so this, when you create an object for this B, so I am creating an object of B. So when I create object of B, it creates a separate copy, B object, and this has two separate properties, A and B. So it has its own copy. When you create object C object, so it has its own copy. So C is extended by B and B is extended by A. Whatever properties I have in A, class A, they will come into class B. Whatever the properties I have in class B will come into class C. So these properties, class C is having A, B, C. Now when I create object for class C, that object copy has all three properties. That object copy has all three properties A, B, C. And if you create object for A, of course it has only one property, and that copy has only property A. A object has only single property, that is what A. When you create new object for A, so that object copy has only one variable. But when you create B object, that class has two. That object has two properties, and C object has two properties. And when you initialize using a object dot value, so this value you will be initializing this value. You will be initializing this value A equal to 10, and this is separate copy. And when you are using B object dot A, this A is going to initialize, but it's not going to disturb this. It's not going to disturb this. That is how, like, you can reuse the values. One is not going to modify the other inherited properties. So here you can initialize a different value. Here you can initialize a different value. And of course, in C class, A property, you can initialize with a different value. You can initialize with a different value, right? So when you access A object dot A, it gives me 10. When you access B object dot A, it gives me 20. C object dot A gives me 40. All are different copies, initialized with different values. Even though the variable is same, but objects are different. Objects are different. That's how you can initialize. Okay. Now, one more point I wanted to let you know. So here, I am initializing a value here, right? Of course, in the class A constructor. In the class B constructor also, I am initializing it or not, a value. In the class C constructor also, I am initializing it or not. So the same thing I am doing in all three classes. Of course, I have a single property here, but just imagine you have 10 properties. Then all the 10 properties you are initializing in the class A, in the class B, and in the class C also. The code is repeating or not? The code initialization logic is repeating or not? Yes. So how can we avoid this? So that is where in the class C constructor, I will initialize the C class specific properties. What is that? C. So I'll initialize this particular property here, but still I have to initialize B value and A value and B value also for class C object or not. Class C object has ABC properties. I have to initialize it. If I am creating a C object, I have to initialize all these three variables. Then from where I have to initialize it? I have values here, A value, B value, but I have to initialize it. That initialization logic I am going to call superclass constructor to initialize A and B values. Now what I'll do is simply I will say, remember the super or this keyword should be the first statement as part of your constructor. Super constructor or this constructor you can call, but that must be the first statement. That should be the first statement. Now what I'm doing, I'm just calling the superclass constructor to initialize this, and a B value and A value. Okay, so let me do it in a reverse way. So A value and B value. Okay, A value and B value, and here A value is A value, B value is B. Okay, now again if you come here, this A value initialization is again repeating or not. This A value is initialized as part of A class constructor, so what I can do is, again, so instead of calling the superclass default constructor, I will pass my A value to initialize it, and here I don't have to initialize it. So that is how I will reduce the code which is duplicated. The initialization logic across the three classes, I am reducing it. I am reducing the duplicate code across the three classes. So what will happen when you are creating a class B object by sending the A value and B value? First it calls the superclass constructor by passing the A value. So what will happen in the superclass constructor? Whatever the value you are giving, with that value, that property A will be initialized and it comes back, and then it initialized with the B value. It initializes the B value. So finally, when you create class B object, A value is initialized and B value is also initialized. In a similar way, when you create object for class C with the values 1, 2, 3, say for example, so super of 1, 2. So this calls the super class constructor, which comes here, which in turns go to its super and it initialize the property A from class A, and it comes back and initialize the property B from class B, comes back and initialize the property C from C class. So here we are reducing, or we are avoiding the duplicate initialization code across the constructor. This is how we do it. This is how we do it. Okay, now it's up to you. If you want to have multiple constructors, yes, you can have it. If it depends on the requirement, you can always have that constructor. So let me just, to avoid the confusion, just I'm removing all the default constructors. See the code now. Just only we are discussing about the superclass and child class constructors. We are initializing the superclass properties from the superclass constructors only. When you are creating a child class object, okay, with given values 1, 2, so it in turn calling superclass by passing the A value 1. So it goes to superclass constructor, it initializes over there, so that here I don't have to initialize that. I don't have to write the logic over here. Okay, so you might feel that okay, only one line of change you can do it over there. That's fine with one variable, but if you have 10 variables in parent class and one more 10 variables in class B, 10 variables in class A, 10 variables in class B, in 10 variables in class C, total 30 variables you are going to initialize it here, meaning that extra 20 lines you have to do it here. Apart from the class C properties, extra 20 properties you have to initialize it. Instead of that, if I simply pass all the 20 properties to its super, it goes there and it takes care of the 10 properties of this B class, and remaining 10 properties class A, it goes there and it initializes it here. So 10 properties here, 10 properties in B class, 10 properties in class C, meaning that so every class properties are initializing in the specific class only, and superclass properties initialization happens in the superclass constructor. That's it. Only what we are doing is we are giving the input to the superclass constructor. So whatever the value I wanted to initialize, I need to just pass that value and call the superclass constructor, which takes care of it. That's how we can initialize the superclass properties in the child classes. Whatever the concept we understand here, we are initializing how to initialize superclass properties from the child class. How to initialize superclass properties from the child class using a super constructor call. Using a super constructor call. In the class B, I'm initializing class A properties using the super constructor call. In the class C, I'm just calling super constructor by passing the required parameters. Do you understand any confusions around this? Let me know. Of course, it gives the same output as like as earlier. Okay, it gives the same output. No issues. Do you understand this? Yeah, if you are already comfortable, yeah, it will be simple. You feel it simple, but for the first time if you are coming through this, definitely, so there is a little confusion of this accessing the parent properties into the child and initializing through constructors and accessing them. Okay, so that's what I just taken with a simple example of classes with simple one property. Shankar, how do you feel? Yes, are you able to follow? Good. Okay, perfect then. Okay, so overall, if you see, we discussed about inheritance type, single inheritance and multi-level inheritance. So there is something called hierarchical inheritance also, meaning that the same parent can be extended by multiple child classes. Okay, or one class can be extended by multiple parents, or the same class is extended by multiple classes, or one class can be extended by multiple classes. So is that possible or not in Java? That's what we'll see. Okay, anyhow, through classes, one class cannot extend multiple classes, multiple other classes, meaning that, say for example, I have a class A extends, say for example, class A extends person, comma, employee. So if I wanted to extend my class with two other classes, this is not possible through classes. Okay, so this is what multiple inheritance, that is not possible in Java. Okay, one class cannot be extended by more than one class, but the same class can be act as a parent for multiple child classes, meaning that my class B is extended class A, and of course I have another class, temporary class, or maybe D, class D, and class D is also extends my class A, extends class A. My class D is also extends class A. Okay, anyhow, this is to add the constructor because it's expecting. Okay, so class D is also extending class A. My class B is also extending class A. Okay, now class A is the parent class for class B as well as class D. So that is what hierarchical inheritance. Okay, here if you see, class A is extended by B and also extended by class D. Right? Anyhow, so we'll see a bit more tomorrow. Okay, so that's all for today.